Alright, you guys. We are back at it. Let me play my jazz music as usual. Yeah, but let's just hop straight into it. So we did all of these tree questions yesterday, as you can see over here. So we might do a review of one of those. Why do these have the same name? Binary tree right side view. Right side view. Alright. Yeah, let's just get straight into it. So continuing on, we got 3 more mediums before we get to the hards, and then we're done with trees. But then we'll work on some tree problems on company-wise tree problems, just because I don't honestly feel great with trees. But alright, given the root of a binary tree, return true if it's a valid binary search tree, otherwise return false. So the left of every node contains only nodes with keys less than the node's key, and every subtree right of every node only contains nodes greater than the node's key. So I think we can validate this by, for example, if we can just check if left is always less than the node and right is always more than the node. You don't have to like validate like down, because if that holds for the ones that are, left subtrees of a given node, then it will mean they're all binary search trees. I think so, at least. So if I have a root, if root is none, then return true, because it's a binary. If root dot left dot val if root dot left and root dot if root dot left or root dot right, root dot left there isn't a root dot left or a root dot right. Is valid. Is valid BST of root dot left. Is valid BST of root dot right. If root dot left dot if root dot left and root dot left dot val is less than root dot val, check if it's valid. If root dot right and root dot right dot val is greater than root dot val, valid BST of root dot right. Otherwise, we can return. See, this isn't gonna work. because it's just not. Wait, let me fix this. So we're at a root. If there is no root, it's valid. If we're at a node. Okay, let's try this. If node.left.val is less than node.val and node.right.val is greater than node.val, then we'll do return is valid BST of root.left and is valid BST of root.right. If that wasn't true, we can return false. No, it is not. This is root. This is root. Root, self. Okay, none type has no attribute now. Okay, wait, if if not root.left and root.right, return true. So this is working, but this only works for ones that are like perfectly balanced or whatever you call it. So how do you fix this? If root.left and like, what do you do here? An if root.left nice thing here. If root.left let me think here. There's only one. If root.left submitted this just to prove it doesn't work. Yeah. I guess we'll use the test case. How do we do this? If it has a left root or a right root, if root dot left oh, we can do that. Oh, we can do this, I'm pretty sure. Wait. I think this works because, so here's my logic. Basically, if it has a root dot left, which is also less than the root dot val, or it has a root dot right, and that root dot right dot val is, then you can return that, because if it's none, it's true. Wait, maybe you don't even have to do all of that. Because if it's none, well, maybe you can do that. Okay, so this works on case 3, but not 2. Oh wait, no. Oh wait, we'll do this. If root dot left or root dot right. If root dot left and root dot left dot val is less than root dot val and root dot right. No, that doesn't work either. We can make this complicated. If root dot left and root dot right, so we have both of them. Root dot right if root dot left dot val. Right dot val is root dot val. If root dot left, so else here would be return false. But if this is true, then return is valid BSD for root dot left, and it is valid BSD for root dot right. Okay, so now if root dot left, if root dot left, root dot left dot is Oh my gosh, why am I always calling this without self? Come on. 0, negative 1,000, 1,000. Okay, so at negative 1,000. Fruit dot left dot val is also return. I'm thinking about that. Let's just delete this. We'll use this just in case. So given a root, so if our root is none, what do we return? I feel like true, because it's a valid binary search tree. If root dot left dot val is greater than root dot left dot val is greater than root dot val. Right. Oh, I never type in self. Okay, so I feel like this works because, let me talk this through. So let's go through this one. If root dot left dot val, if it violates the BST, we return false. If this one violates the BST, we return false. But if neither of these violate the BST, then we go down to each of them. And it's fine if they're none, because it'll return true if it's none. Okay. Let's do generator from first. BST visualizer. Okay. want to, whatever. Visualize the So why is this not valid? Because it's a tree of every node and only contains only nodes with keys less than the node's key. Because we're just checking that this one violates because so the right cannot ever be less than or equal to this. And the left can never be less than, more than or equal to this. What about you? I don't know. How do you do this? Let's see. Takes in the node and what it's left and right bounded is not. Sorry about that, you guys. So it seems if it's valid, return valid, the no.left when it's left, and no.val, the right limit. So the highest it can be is no.val. The highest it can be is the no.val. The highest it can be, wait, let me think. The highest it can be is no.val. Okay, I mean, that makes sense. Wait, let me think. It's valid BST, valid BST, taking a node. Oops, wait. Taking a node. Left bound and the right bound. If it's null, return true. If the node, if not, left is less than node, and right is greater, or left bound is less than node, and right bound is greater, then return false. Else, which means it does fall within the proper bounds, return valid BST for no.left, where the left bound is left bound and the right bound is no.val, and valid BST for no.right, where the left bound is no.val and the right bound is right bound. And then return valid BST for root, left is negative float infinity, and right is float infinity. Okay. Sweet. I'm going to mark that as a yellow. That was pretty, I would think I could have done better. Valid binary search tree. Routine 2026. Okay, yellow. Not green. Not green. Okay, there we go. Alright, let's see. Given the root of a binary search tree and an integer k, return the kth smallest value in the tree. The root, the kth smallest, which means the kth smallest is interesting. See, they don't give you test cases that really help you visualize, but that's okay, I guess. It makes it a challenge. So 1 is the first smallest. So the smallest. Kth smallest value. 2, 3, 4, 5, 5. I mean, there's a dumb way to do this, and I mean, I really want to do it the dumb way, but which would be to just grab all of the values and then sort it and then grab that kth smallest. But that's clearly not what they want. If it, so every time you go down, I don't know, I mean, this is tough. I'm gonna do it the brute force way. Scene equals scene is that for if there is a root, scene dot append. See what this does. We have to return something. Okay, whatever. So I need to append self.scene. No, I did not. Do I have to do non-LeetCode? Let's see. Maybe. No binding for non-LeetCode scene. Scene, self.scene, scene. Defined. Left where k is what? Okay. See, I'm overcomplicating this. Take scene. Put this in here. What is going on here? Why am all this for a terrible method. Okay. 4325. That's good. 213. Scene dot sort the kth smallest. So return scene at so smallest at the front. The first one was the second. K at scene at K. So K minus 1. Yeah, that's horrendous. I mean, how do you do this? If not DFS. Oh, sorry about that, you guys. I just looked over to my second screen and saw that our thing had completely cut out. So I did this brute force, which is over n log n. So I suppose if they gave me a tree of 10 to the 7 or something, or 10 to the 8, this wouldn't work. But they don't. But I do want to do the of n, and it is kind of dummy to not realize that if you do left, no, then right. Left 3, 4. Left. All right, so DFS seeing. Node, what do we do? Return this is messed up. Node. If not node, return else so we have a node, so index out of range. Oh wait, here we're gonna do DFS through. If not, no. What is wrong here? Oh my gosh. DFS just changes to node. Okay. I'm also putting that as a yellow. Actually, I mean, I could solve it in OM again, but like, I feel like it's fair to put it as a yellow because so honestly I could go on and do this one. Tuner pre and pre is 1, 2, 3, 4, and is 2, 1, 3, 4. Why do I need? What is up with Moore's travel, bro? Alright, we'll do this tomorrow, I guess. for now, let's revisit one of the ones. Oh wait, let's check what today's problem is. Medium. Topics, have done that. Do binary tree level order reversal. Order traversal. Okay. Do a level order by level. So Q is DQ, and then we'll have our answer, and then we'll have Q append root. Then while we have a Q, occurs that for I range the length of a Q, we'll do the node is Q dot pop left, and then let's see, Q is node dot pop left, and then if that's a node, then Q dot pop left. If node, we'll do cur dot append dot left cur. Oh wait, no. Oh yeah, cur dot append. Then we'll do Q dot append dot left Q dot append dot right. And then if cur, we'll do if cur dot cur returns. Beautiful. Alright, let's go ahead. Like, what are people doing over here? Okay, you know what? I'm not even gonna look. So we did this one, we did this one. Subtree of another tree was yellow, but it was a green, so let's do that one. Subtree of subtree of another tree. Cover my screen. Oh, I don't need to. Okay, wait, it is same tree. One, two. Okay, I'm really glad I got that. That is a medium. We turned in, I mean a yellow we turned into a green. So we did these today. Count good nodes. What is count good nodes? Count good nodes in a binary tree. Good of the path, there are no nodes with a value greater than x. Number of good nodes. There are no nodes with a value greater than x. There are no nodes. Root x is good from. So 3 is good. 4, there's nothing greater. Okay, let's think if x equals 0, max equals 50. Float infinity. Left count taken a node and max. If there is no node, turn. If node by val is what? If it's greater than or equal to max, then ants plus equals 1 and our new max is going to be val. We'll call count left with the max and right with the max. Else just do the same thing. What about the left? Max. Right with the max. Okay, so we can actually reduce the code by just doing this. Okay, and then here we'll just call count with root and the max being float infinity, negative float infinity. Okay. I think you have to do non-local here. stupid. Returning ants. 53 milliseconds, that seems long. No, I guess not. How big is this tree? Okay. Pretty cool. Okay. Okay. Oh, count nodes and good binary tree. Count nodes and good binary tree. Count nodes and good. I mean, yeah, I don't know. What should we do? Suburb product less than K. It's been a week. Suburb product less than K. Interesting. So apparently, I've done this. Given an array of integers and nums and an integer k return number contiguous arrays where all products of this term is less than k. Is this the at most problem? Oh wait. Where did I do this? When did I do this? It's subarray product less than K. Apparently I've done this. Do I do this in LeetCode? Summary product less than K. I don't think I did this one. I did this one? I wrote it down as a 811. I don't think I did this. Given an array of integers. I mean, is it sliding a window? Let's see. Cur equals 1, and then cur times equals the num, and while cur is greater than strictly less, greater than or equal to k. Plus equals 1, and I do feel like I've done this. This is weird. This is weird. What? I feel like I've done this, but I guess it says I haven't. While cur is more than or equal to k, L plus equals 1, and cur divided by nums and L. Right, and then you just can do Is this one of those? Let me think. If you want bang, bang. So 1, 1. 3. 1 plus 2 is 3. Plus 2 is 5. It's just ants r minus n plus 1. This is weird. Okay, so center equal to 1. I swear I've done that. Alright, well, I guess whatever. How many are we at now? 225. When am I going to get my next contest rating? Alright, well, I'm satisfied with that. And that puts us at an hour today, so I think that's good. You know, it's 11, it's almost midnight, you know, so I don't want to push it too far. But tomorrow we can do this one, and which seems kind of hard, and then we can move on to the hards, which is going to be tricky. But like I said, once we do all of the tree ones, we'll focus on more tree, like company-related tree problems. What's his name? LeetCode patterns. Like here we can go and we can do, where is it? Binary tree, binary search tree. Here we can do these. See what's the most tagged and whatever. Oh, I also have another one where it's like, I don't know where it is. What is it? It's like LeetCode or company. Or no, it's not that. It's OA. No. Where is it? It's like a GitHub. I don't know, but anyway, we can do all these. Okay. Alright, well, I will see you guys tomorrow. Take care.